Welcome again to the continuation of the topic experiment on triangular prism. Please, if you are new in my channel, I welcome you once more. I appreciate you so much for being part of my channel, for clicking subscribe, for sharing my videos to all the friends you have so that they will also learn as well. If you have any difficulty or question, you feel free to ask the question on the comment below. Okay? Please, these videos are in many parts. We have posted many parts of it before now, up to 2 parts of it. Now, I will love it so much. I will like it. I will love it if you click Chidon's Daniel Introduction to Physics Practical. You will see video on that and you will have a lot to learn concerning practical physics and how to plot graphs on it. If you also click Chidon's Daniel Introduction to Triangular Prism Experiment, or how to perform experiment on triangular prism, you also see video on that. If you also click videos on how to manipulate readings on triangular prism experiment, that is how to get your reading without performing the experiment, that is using formula method and your calculator, you will also see what I explained on that. So feel free to see the videos just mentioned before you come to this one you're watching, because this is the continuation of those videos. In this video, I will not tell you how I got all these readings because it was discussed there. Okay, what I want to concentrate on is how to plot your graph on triangular prism experiment. Now, it is very important to note that before you do anything on your graph sheet, I repeat, before you do anything on your graph sheet, it is very important that you write your date first. So, we'll write our date, put your date, then write the title of the graph, a graph of D in degrees against I in degrees. So as you write the title, attach the degree, the unit to it. If it has unit, then put your date. Very important. Every experiment must have its date. It's very important. Then also ensure that you put your scale. You can put it on the top, on the bottom of your graph, depending. That is when you have known the scale you have to use before you do that. So this is a typical example of standard graph sheet. A typical example of standard graph sheet. The bigger boxes you are seeing, it is called 2 cm. The bigger boxes you are seeing is called 2 cm. Okay? Then, if you merge 2 of the bigger boxes, if you merge 2, the 2 will be called 4 cm. If you merge the 3 will be called 6 cm. So you have to have it in your mind. And each of the bigger boxes have 10 small boxes. 10 small boxes. So all you do is from here to here, you have 10 small boxes, 10 small boxes, 10 small boxes. So when you merge this and this, you'll be getting 4 cm, because this is 2 cm, 2 cm, 2 cm, each of them 2 cm, 2 cm, 2 cm. So you have it to your mind. You can put your scale on the top of this graph sheet or on the bottom of it. It depends on you, but you must indicate the scale you use. Now, look at your table of value. You will notice that I is in increasing order. 30, 40, 50, 60, 70. It is in increasing order. Whereas D I can't say it is in increasing order or decreasing order. Look at it. This is big. Then it get down to 36.6. It get down to 35.6. I expect it all to go down. But it come at this point, it started increasing and started increasing. With this, when you are plotting a graph of D against I, when you are plotting a graph of D against I, the implication is that you will have a U shape. The graph will be a U shape, as if you are plotting quadratic graph, U shape. That means it decreases at a point, then increase. You get it? Then you have to note that. Then they say we should start both axes from the origin. Please, if you start by writing origin O, O here, you will notice that if you write O, 10, 20, 30, 40, 50, and so on, you will notice that you will have space because you only start from 30 to be plotting in the I part. So what I will do is that for me to start from the origin, see what I will do now. I'm plotting graph of D against I. I will now say, okay, D goes this way. Total is 42 and the smallest is 35. So what I will do here is, I might say, I will come here. Remember, in rule of graph, your graph will is meant to cover at least 2/3 of your graph sheet. The graph you have to plot is meant to cover at least 2/3 of your graph sheet. So that means if I come here, I can say, let me come here and put, instead of writing 0, here, because I know that here it started from 30 and here it started from 35. If I put 0, and put 10, 20, 30, here will be starting from 30. And if I put 0, here will be starting from 35. So starting from 35, there will be excess space here not used. So what I will do is, I will say that because they say starting both sides from the origin, I will do zigzag like this, That tells me that I am not right, that this zigzag is telling me that I am starting from the origin, but I am not writing 0, here. So for here, I will put my D in degrees, and this my I in what? Degrees. I will put it this way. Then here, my D starts from what? Here, I will be having my I 30, 40, 50, 60, 70. That is my I. Then my D, if I start 30 here, I will write here, let's say 34. I'm trying to see how to achieve 42.99 without leaving spaces. Then I will have 38. Then I will have 42. And I will have 46. That means 34 minus 30 is 4. 38 minus 34 is 4. This 4. So it means that on my scale here will be scale on the axis. I'll be having 2 cm to represent 4 degrees because it is in degrees. Then for on the axis. Then for I axis, I will say 2 cm represent 10 degrees on I axis. That means I put here in 10, 10, my 10, 10, and that is it. So it does not mean that you must start 0, 0. If you start 0, 0 in this type of graph, you will see that there will be vacant, that empty space that you will not make use of. So because of that, you have it this way. Now, what you will do now is you start up your plotting. Here is 42.9, approximate it to nearest degree, 43. 43 against 30. This is 43 around here against 30. So I can put it here. Let's say 42. Then watch. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I will have 10 smaller spaces here. 46 minus 42, that is 4 divided by 10, 0.4. Here will be 42.4. So what I did is I said 46 minus 42, that is 4. Divided by 10 boxes, it will give you 0.4. That 0.4 is the value of each of the small spaces you are seeing. Small boxes you are seeing inside here. That is the value. So we now say 0.4. 42.4, 42.8, then 43.2. The third part, 43.2. I'll put it like this. Against 30. Then 36, approximately 36 against 40. This will be 36. In between what? 38 and 34. Against 40. I will have it like this. Then the next one, 36 against 50. 36 against 50. I will have it like this. Then the next one, 60 against 37. 60 against 37. I will have it like this. That is 60 against 37. Then 70 against 41. 70 against 41. 41 should be around here. I will have it like this. So what I will do, I will use my broom to connect. I'll use my broom to connect. So you have it a U shape. Okay? Now we want to get our minimum deviation. Our minimum deviation. This is 36. Minimum deviation is, trace here the lowest value of the curve. Trace it. If you trace it, you will be seeing it here. So it will be falling between 30. Okay, so it falls at 35.5 degrees. Then you trace it from here down to here. So you now see that the lowest value you have here, you call it D minimum. That is the minimum value you have in the D part. And the minimum value you have on the I part, we call it I minimum. That is in between 40 and 50. So you have 55. But in between 40 and 50, you have 45 degrees. Then what you also do, you say obtain the minimum deviation D min and its corresponding value of angle of incidence. We have gotten it. We now say that D minimum is equal to 35.5 degrees. Then I minimum is equal to 45 degrees. Okay? Now the next is estimate the standard error in D minimum and in I minimum. Estimate the standard error in D minimum and I minimum. Now to estimate it, because D minimum is an angle and I minimum is also an angle, the lowest value you get from measuring instrument we have for measuring angle, that is protractor. The lowest value you will get there is 1 degree. That is, it's calibrated this way. You have 0, 10, 20, 30, and so on. In between 0 and 10, you have 10 small gap. In between 10 and 20, you have 10 small gap. So 20 minus 10 will be giving you 10. 10 minus 0 will be giving you 0. Divided by, so if you say 10 minus 0, divided by that small gap, which you have 10 spaces, up to 10 spaces. So you will be getting it to be 1 degree. I repeat, if here is 0 and here is, let me use what you understand. Here is 10. You will see small line that is up to what? 10. Small line between 0 and 10, they are up to 10. So what you do is I say 10 minus 0, 10, divided by that small angles, which are 10. It will give you 1 degree. It means that the least angle you can get, which is the minimum deviation on, is 1 degree, and the angle of incidence is 1 degree, because that is the least value of theta you can get from the instrument called protractor, for instance. So an instrument used for measuring angle, the least value you can get there is 1 degree. So you just write 1 degree here, 1 degree. Then find the mean of A, find the mean of the angle of prism A. Look at it, means add all of them and divide by 5. So we'll be having 59 plus 60 plus 61 plus 59 plus 61 divided by 5. That will be giving you 60 degrees. So you say your A is equal to 60 degrees. The mean of the angle is 60 degrees. Then the standard error in the mean. Standard error in the mean, we call it SEM. The formula is range all over n. That means range means highest minus lowest. The highest is 61, the lowest is 59. 61 minus 59 will give you 2. All over, how many are there? 5. That is approximately 0.4 degrees. So that means our SEM, standard error in the mean, is 0.4 degrees. So we'll write it SEM equal to 0.4 degrees. Then the next one, deduce the refractive index of the glass. Okay, refractive index is equal to sine dm plus A over 2 divided by sine A all over 2. And our A is 60 degrees. Our dm is 35.5 degrees. So what we say is 35.5 plus 60. We'll be having it 35.5 plus 60. Then we say divided by 2. That will be giving us 47.75. Then 60 over 2 will be giving us 30. So we now say, let's put it well. Sine dm plus A all over 2, which is 47.75, divided by sine 60 over 2, which is 30, will be giving you what? Approximately, when you press it in calculator, it will give approximately 1.48. So remember, in the video, or the starting point of this video, we realize that our refractive index we are to use is 1.48. That is where we started the manipulation from. So you see now we have gotten into the 1.48, and I said the range, the best range of value for refractive index of triangular prism is between 1.48 to 1.52. That means it is the best. The farther you get the answer, the more they subtract mark from you. Remember, from this graph, it's sent to our mind that it is not all the time you will be having straight line graph. So if you have a straight line graph in this graph, it means that you've got it wrong. Whether negative graph or positive graph, whichever one, if you have it, you are wrong. It must be in a parabola form. We call this graph parabola graph. So it must be in parabola graph so that you can get your minimum deviation from your graph and minimum angle of incidence as well. As you can see from this video, we have seen that it's very possible to perform your experiment without touching apparatus at all. Only use your calculator, your pen, and your graph sheet. That means you can perform this experiment in the midnight where there is total darkness, or if you have problem of eyesight, then you can also perform this experiment as well. As you enjoy this video, please feel free to click thumb up for me. That means you like my video. Comment as well, click subscribe, and please share it to your friends as well so that they will enjoy it too. See you in our next practical class.